Hello everyone. Thank you very much for having me at the Slovenia Ethical Hacking Conference 2022. This presentation is going to be focused on bypassing UAC with a tool called UACMe. And again, this is primarily going to be focused on Windows privilege escalation via bypassing UAC. All right, so my name is Alexis Ahmed, and let me just tell you a little bit about myself before we get started. So, as I said, my name is Alexis Ahmed. I am a senior penetration tester at HackerSploit Cybersecurity. I'm also a red team instructor at INE, and I also create content on my YouTube channel. Some of you may be familiar with it. It's youtube.com/HackerSploit. And you can take a look at some of my certifications. I've also created cybersecurity training for various companies like Linode, EC Council, as well as a couple of others that I haven't added on here. If you want to follow me and essentially keep up to date with what I've been doing, you can take a look at my Twitter. That's at HackerSploit. And yeah, that's really just who I am. I am a penetration tester by trade. I also delve into red team operations, and I've really been focused on privilege escalation over the last 2 years. And that's why I actually wanted to actually perform or showcase this particular technique, primarily because not a lot of penetration testers and red teamers actually know about it. So let's get started by getting an understanding of what we'll be exploring within this conference, within this particular presentation. So we're going to start off by getting an introduction to UAC, understanding what it is and why it's there. We'll then get a high-level overview of bypassing UAC and its actual relation to privilege escalation. And we'll also get an introduction to the tool UACMe, and we'll take a look at how it can be used to bypass UAC on Windows in order to elevate your privileges. And then, of course, I'll perform a live demo with a proof of concept to showcase how this works and to actually verify that indeed this technique does work. So again, getting started, I just want to go over privilege escalation really quickly. So privilege escalation essentially consists of techniques that adversaries use to gain high-level permissions on a system or network. Now, adversaries can often enter and explore a network with unprivileged access, but require privileged access or elevated permissions to follow through on their objectives. Common approaches are to take advantage of system weaknesses, misconfigurations, and vulnerabilities. So again, when it comes down to privilege escalation, especially Windows privilege escalation, there's multiple techniques that you can use to elevate your privileges, like kernel exploits. However, that really isn't stable and is not recommended to be performed in an environment or an enterprise network, right? Because you may cause systems to crash, and that may lead to data loss. And then, of course, there's a plethora of other techniques that essentially leverage weaknesses within Windows features, misconfigurations, etc. However, as we've had newer versions of Windows released, it's becoming increasingly difficult to elevate your privileges. However, one thing still stays, it actually stays standard or common between most new versions of Windows, and that is user account control, right? So the MITRE ATT&CK technique relative to bypassing user account control states the following. So adversaries may bypass UAC mechanisms in order to elevate process privileges on a system. Windows user account control allows a program to elevate its privileges, tracked as integrity levels ranging from low to high, to perform a task under administrator level permissions, possibly by prompting the user for confirmation. The impact to the user ranges from denying the operation under high enforcement to allow the user to perform the action if they are in the local administrators group and click through the prompt, or allowing them to enter an administrator password to complete the action. Right, so that is from the MITRE ATT&CK website, and I just wanted to go through that particular technique because this is what we're going to be exploring, right? Now, many of you will already know what UAC on Windows is, right? So UAC stands for User Account Control. It is a Windows security feature that was introduced in Windows Vista, or from Windows versions, Windows Vista onwards. So Windows Vista, Windows 7, Windows 8.1, Windows 10, etc., as well as the actual server editions. right? And it was introduced into Windows to prevent unauthorized changes from being made to the operating system. So I'll give you an example. Whenever if you're working on Windows, if you are using a user that's not part of the local administrators group, or really it doesn't have any administrative privileges, if I try and install a new piece of software or run a setup file, a dialog box will show up, and that is the actual credential prompt, the UAC credential prompt. It will essentially prompt that user to specify the administrator's password before they can actually run that setup file or install any new software. So that was really why UAC was introduced. Now, if you've ever tried to execute a program or a setup file with administrative privileges as a user that is part of the local administrators group, you'll get a different UAC prompt, and that is going to be the consent prompt. So instead of asking you to provide the administrator's password, it'll essentially ask you to say yes or no. And if we take a look at the following images here, you can see that this is your consent prompt. So if you are a local administrator, or you are part of the local administrators group on Windows, and you try to run any program as administrator, you'll be prompted with the following window. If you're not an administrative user, or you're not part of the local administrative group on Windows, then you'll be essentially be prompted to provide the administrator's password. All right, now, again, I've explained this over here. A non-privileged user attempting to execute a program with elevated privileges will be prompted with the UAC credential prompt, whereas a privileged user will be prompted with a consent prompt. Attackers can bypass UAC in order to execute malicious executables with elevated privileges. Now, one of the challenges that every penetration tester faces is if I get remote access to a Windows system, and the privileges that I obtain, or the user account that I have access to, is part of the local administrators group, then at that point, I really do not have an elevated session. The reason for that is because, again, that user account doesn't have administrative privileges by default. You actually need to go through UAC whenever you're executing a program with administrative privileges. So it's a very good security feature that Windows introduced. And again, it can be quite difficult to bypass because, as I said, regardless of what user account you get access to, you will in some way or form need to bypass UAC unless you get access to the administrator account, which is very rare to begin with. So you can see that this is your typical, let me just bring that here. So this is your typical UAC security levels prompt on Windows that allows you to essentially configure the notifications when a program is executed with administrative privileges, right? So the default setting is typically right over here, or by standard, it should be set at this level, right? So again, this particular technique will essentially require the target system to have the UAC level, the actual UAC security level set to medium or low. If it's on high, then again, it'll become very difficult to bypass UAC because that will notify the user, whenever a program is executed, regardless of whether the user is executing it with administrative privileges. So in terms of bypassing UAC, in order to successfully bypass UAC, we will need to have access to a user account that is part of the local administrators group on the Windows target system. And of course, if you're a penetration tester, this is something that you've come across quite a lot. So for example, if I obtain a Meterpreter session on the Windows target, and if I take a look at the permissions that I have, I may be a user that's part of the local administrators group, but I still cannot do anything that requires elevated privileges. So I cannot migrate processes. I cannot dump the NTLM hashes from the LSAS process cache. I can't really do anything. In order for me to get the administrative privileges, I need to bypass UAC, right? And that will, again, we'll actually get to that during the practical demonstration. So UAC allows a program to be executed with administrative privileges, consequently prompting the user for confirmation or the administrator's password. So this is what we're trying to bypass, right? Because if we have access to the target system via a reverse shell or Meterpreter session, whenever we try and execute a program with administrative privileges, it's going to open up the consent prompt on the target system, but we cannot access it because we don't have physical access to the Windows target system. And as a result, the end user or the individual using that system may click on yes or may click on no. So again, that's something that can be quite difficult to deal with, and this is where the UACMe tool comes into play. All right, so as I've already explained, UAC has various integrity levels ranging from low to high. If the UAC protection level is set to below high, Windows programs can be executed with elevated privileges without prompting the user for confirmation. Now, there are multiple tools and techniques that can be used to bypass UAC. However, the tool and the technique used will depend on the version or edition of Windows that's running on the target system. And this is something that I'll clarify in a few seconds. So now that we know what UAC is, let's get an understanding of what UACMe is. All right, so UACMe is an open source, robust privilege escalation tool developed by Firefox or Firefox. It can be used to bypass Windows UAC by abusing the built-in Windows Auto Elevate backdoor. So if you've used Windows before and if you're a penetration tester, then you should be familiar with the Auto Elevate tool on Windows. You can take a look at the GitHub repository. It's attached to these slides. That is github.com Firefox UACMe, or you can just perform a quick Google search. Now, the UACMe GitHub repository contains a very well documented list of methods that can be used to bypass UAC on multiple versions of Windows, ranging from Windows 7 to Windows 10. And the great thing about the GitHub repository is it contains a detailed description and documentation regarding the various techniques that you can use to bypass UAC and whether or not they've been fixed, and if they were fixed, what versions of Windows they were fixed in. So in terms of the techniques or the keys, which you'll get to see in a few seconds, you will be able to determine which one will work best based on the version of Windows that's running on the target system that you're trying to elevate your privileges on. So it can allow attackers to execute malicious payloads or arbitrary commands on a Windows target with administrative or elevated privileges. So for example, and this is what we'll be doing during the practical demonstration, we can generate a Meterpreter payload and utilize UACMe to execute that Meterpreter payload with elevated privileges, consequently providing us with an elevated Meterpreter session or a Meterpreter session with anti-authority system privileges. Now, the UACMe GitHub repository contains or has more than 60 exploits or techniques that can be used to bypass UAC depending on the version of Windows running on the target. So the prerequisites to replicate this particular attack or technique are the following. So you need to have access to a user account that is part of the local administrators group. That's very important. And the UAC level should be set to default or low. If it's set to high, then the chances of this working are very low. And in my testing, I haven't been able to bypass the high configuration or the high security level. All right, so for the live demonstration, this is my lab environment. I'm going to be using Kali Linux to essentially perform all the attacks. The target system is running Windows 10 Enterprise Edition build 17.763, which I've already tested on, and I've been testing it on multiple versions of Windows 10 as well as Windows 8.1, and now my current testing is on Windows Server, but that is still in testing, and of course I'll be sharing my feedback on that. But for now, we're going to be focusing on Windows 10 Enterprise build 17.763. Okay, so the live demonstration. So what I'm going to do is I'm just going to switch over to my browser, and I'll take you through the process of actually downloading the Akagai source code and compiling it into the executables and explaining how everything works from a technical standpoint. All right, so let me just switch over to my actual system. All right, so I'm currently within my browser and I'm currently on the GitHub repository here. So that is UACMe. And you can go through the GitHub repository. In fact, I recommend that you do. So taking a look at the description, you can see this is used to defeat Windows user account control by abusing the built-in Windows Auto Elevate backdoor. These are the actual system requirements. So you need x86 or 32-bit and 64-bit versions of Windows. It works on Windows 7, 8, 8.1, 10. And again, as you can see, it works on some server versions, which is what I was currently testing. And you then require an admin account with UAC set on the default settings required. So in terms of the usage, you can see that you can run the executable from the command line or from a command from an actual command prompt session, regardless of whether or not it's remote. It can be also it can also be done locally. So the executable to perform the actual UAC bypass is called HEK.SI, and depending on the target architecture, you can either compile it into 32-bit or 64-bit. And the usage or the syntax is fairly simple. You specify the HEK.SI executable, or you launch the HEK.SI executable, specify the parameter, or rather the key. The key is the technique, which I'll get to in a second, and then the parameter. So in our case, the parameter will be the actual path to the malicious meterpreter payload that I've already generated. So what we're essentially going to be doing is running HEK.SI and then specify the technique, which is the key, and then specify the actual payload or the executable that we would like to execute with elevated privileges, therefore bypassing UAC. All right, so you can see that the first parameter is the number of method to use. The second is an optional command. It can be an executable file, including the full path to run. The second parameter can be empty. In this case, the program will execute an elevated cmd.exe from the system32 folder. Now, this will really not be helpful if you're attacking a system remotely and you have remote access, because if you're using Meterpreter and you're using a Meterpreter session, then it'll not actually spawn the elevated command prompt. It'll actually open that up on the target system. So I don't recommend doing that if you have remote access. Now let's take a look at the actual keys. So these are the various techniques that you can use. And for example, in terms of the usage, if I wanted to use the technique 1, which is the actual type is DLL hijacking, the method is ifile operation, and the target is sysprep.exe, I can say HEK.SI 64.exe 1, that is the key here, and then the actual path to the executable that I would like to execute with administrative privileges. Now, the keys are very important because they essentially contain the author information, the type, the method, the targets in terms of the executable that is going to be used to bypass UAC, the components affected in terms of the DLLs, and then the implementation. And this is the most important piece of information here. This is the works from information. So this will tell you what versions of Windows this will work on from Windows 7 onwards. So you can see Windows 7 build 76000 or build 7600, and then it was fixed in Windows 8.1. So again, this will not really be helpful unless you're targeting Windows 7 build 7600. So this will give you a good idea of what key or technique you can use to bypass UAC. All right, you can go through all of them. There are about 60. In my case, we are going to be using key 33 or technique 33, which I'll just go to. This is, you can get the information regarding the author. The type is shell API, and it targets the FOD helper.exe. And then the components, you can see this is attacker defined, and this works from Windows 10 TH1. This is build 10.240, and it is currently unfixed, which is why I've been able to actually test it and get it to work on the current build that we will be targeting. All right, so these are all the techniques. As I said, you will need to go through them yourself, as I will not have enough time to cover all of these techniques. So what I can do here is, let me just close up the keys drop-down menu. It'll give you additional notes that are very, very important. So you can see method 30 and 63 are later implemented only in the 64-bit version. So that means you can only utilize some techniques with the 64-bit version of HEK.SI. And you can go through the notes, and then it gives you examples. So for example, if I wanted to use technique 23, I would launch the HEK.SI executable, specify the key 23, and that will open up an elevated command prompt session. However, if I want to execute, for example, calc.exe, I can just specify the path to the exe, and as an attacker or as a penetration tester, this can be a Meterpreter payload or just an executable that contains malicious code, and you can execute it as administrator. Now, it doesn't have to be an executable. You can also execute PowerShell scripts, so you're not limited to just executables. All right, so it'll give you a warning here in terms of the antivirus detection. Now, in my case, or in my scenario, the latest compiled version that I was able to compile actually is not detected by Windows Defender. However, it may be detected by third-party antivirus solutions like Malwarebytes and a few others. So you can go through the warnings here. And then the Windows 10 support and testing policy, it'll give you information regarding the versions and editions as well as build numbers that it has been tested on in terms of Windows 10. And you can see right away, insider builds are not supported as methods may be fixed there. So again, I don't recommend running the HackerSploit executable on insider builds. All right, so in terms of the other usage, you can go through and take a look at some of the usage or where this particular tool has been used before. Obviously, it's been used by quite a few APT groups, and until we actually discover, or some of these APT groups have actually been found or discovered, we'll not know the true extent as to how how many APT groups have been using UACMe or the HackerSploit executable. So in terms of pre-compiled binaries, UACMe does not contain pre-compiled binaries or does not provide them. You can see that you'll need to compile it yourself, and you'll require Microsoft Visual Studio 2015 and later. And the reason for that, as you can see here, is that the most important reason is primarily because GitHub will actually flag this GitHub repository as malicious if it contains malicious binaries. So that's why they don't have pre-compiled binaries. And of course, I really like this notice here. By giving compiled binaries to everyone, you make the life of script kiddies much easier, because having the need to compile from source works as a perfect barrier for exceptionally dumb script kiddies. Right, so again, compiling this is very simple. These are the compilation instructions here. You can see that you'll need to specify the actual platform toolset depending on the version of Visual Studio you're using. And that can be done by going to Project, Properties, and General. And of course, I'll go into this right now. And again, compiling it is fairly simple. You can either compile the debug executable or the actual release executable. Now, as I said, in order to bypass UAC, you'll need to compile the HackerSploit executable. So in this video, I'm only going to be focusing on HackerSploit right over here. So you can compile the source by going back into the actual source directory, or just downloading the entire GitHub repository as a zip file, or you can clone it with Git. Once you've done that, you can then open up the actual project file under source. There we are. And you can open it up in Microsoft Visual Studio. And that's exactly what I'm going to do. Now, if you take a look at the units here, you can see that HackerSploit is the main executable file. It contains the payload and data units. You can see that Akatsuki is x64 payload. This is the WoW64 logger. And of course, I'll really not be diving into them. But these are really all the payload data units. We are primarily going to be focused on HackerSploit. So once you've downloaded the source or the GitHub repository, just open up the project UACMe within Visual Studio, and I'll now switch over to Visual Studio and show you how easy it is to actually compile. All right, so I'm currently within Visual Studio, and you can see that I've opened up the UACMe project, and there we are. You can see I've opened the project file, and in order to actually compile it, the first thing you need to do is, of course, head over into Project and Properties, and ensure that the actual SDK and the actual project tools are matching with the GitHub repository. So if I just switch over to the browser, let me actually show you that right now. So you can see that I'm currently using Visual Studio 2019. So you need to specify the platform tool set. And for Visual Studio 2019, ensure that that is set to version 142. And then it provides you with additional information whether you're using version 142 and above. So again, if you're using version 140, then select 8.1, and then you need to make sure that the Windows 8.1 SDK is installed. However, in my case, I use the default Visual Studio installation, so I have the Windows 10 SDK installed. All right, so let me just switch back over to Visual Studio. So if I click on HackerSploit, right click on it and click on Properties, again, you can see that the Windows SDK version is set appropriately, as well as the platform toolset that's set to version 142. And in terms of compilation, you can click right over here and specify release or debug, and then specify the architecture in terms of the binary that you'd like to generate. So you can generate Win32 or x64. Once that is done, right click and you can then build the solution. So that'll just take a couple of seconds. As you can see, the build process is currently being done here. So there we are. You can see that it was successful, and it'll actually give you the path to the actual Akagai executable. So that is under source Akagai output x64 release akagai.exe. So what you need to do then is, of course, copy this over to your penetration testing distribution. I've already copied my release version into my Kali Linux VM, which is what I'm going to be switching into next. And we can get started with the practical demonstration. All right, so I'm back within my Kali Linux VM, and I've already obtained access to the target system, or an initial foothold on the target system. And I have obtained a Meterpreter session. So, if I say sysinfo, you can see that the target is indeed running Windows 10. That is build 17.763, and it's a 64-bit version of Windows 10. And if I say get user ID, you can see that I currently have access to the IE user, which is it's an unprivileged user account that is part of the local administrators group. So if I say get privs, you can see that these are the only privileges that I have, which means I really cannot do much. And of course, if I open up a shell session here, I'll give that a couple of seconds. That'll open up a command prompt, and I can then say, for example, who am I, or just list out the users on the system. So net user, and you can see we have the typical administrator account, and then we have the IE user, which is what we currently have access to. And then I can say net local group administrators to essentially list out the members of the administrators group or the local administrators group. And you can see that IE user is part of this, is part of that group, which means that if I had physical access to the system, I could perform administrative tasks. But as a penetration tester, I only have remote access via a Meterpreter session. So again, if I just terminate this channel and head back over into Meterpreter, if I wanted to migrate into a process, for example, the LSAS process, you can see that I've just got the process ID. I can say migrate 628, hit enter. You can see that we have insufficient privileges. So regardless of whether or not we are part of the local administrators group, we still need to find a way of bypassing UAC in order to elevate our privileges. All right, so as I said, I've already got the Akagai 64 executable on my desktop here under a folder called UACMe. So what I'm going to do is, firstly, I need to transfer this onto the target system. And before I do that, I also want to generate my Meterpreter payload. So what I'll do is I'll just open up a new, I'll just split the window here. And I can, you can easily generate a Meterpreter module with MSF Venom. So I'll say Windows x64 Meterpreter reverse TCP. And I'll specify my IP address. Now, of course, if you're an attacker or red teamer, you'll probably be doing this from a C2 server. So you need to specify the IP accordingly. In my case, my Kali Linux IP is the following. L port, we'll set that to 1234 just to keep things simple. And we'll output this as exe, and we'll just call it shell.exe. Right? I'll hit enter, and that's going to generate the malicious payload that we want executed. So we'll give this a couple of seconds. Once it's generated, I'll then set up the handler. So you can see it's generated. It's called shell.exe. So I'll just move shell.exe into my desktop under UACMe. There we are. And I'll head over into desktop UACMe. You can see we have Akagai and shell.exe. I'll now set up my handler. So, I can create a resource script, or I can just launch up MSF console. I'll create a resource script to set up the handler. I'll call it handler.rc. And I can then say, use multi-handler. Set the payload to the one that we had used when we were generating it with MSF Venom, which is x64 Meterpreter reverse TCP. Set the lhost options accordingly. That was my IP was 10.10.10.10. Set the L port to 1234 and then run. So I'll write and save that. Write and quit. And then I can say MSF console resource script handler.rc. and that'll set up the actual handler for me. And once the handler is set up, we can then upload HackerSploit onto the target, as well as the actual shell.exe that we want to execute with elevated privileges. So again, just to verify, you can see this is get user ID, that is IE user, get privs. So on this window, this is the unprivileged session that we have. What I'm going to do now, if I print my working directory, I'm currently within C users IE user. I can either upload the files here, or I can upload them to the temp directory, but just for the purpose of this demonstration, I'll upload them to this directory. So I'll say upload. I'll use the built-in upload functionality within Meterpreter, and I'll say home Kiali desktop UACMe. Let's upload HackerSploit64.exe first. So that's uploaded. We can then upload shell.exe. There we go. Hit enter. And if we list out the contents of this directory, we should see that we have both of these executables. So we have HackerSploit x64 here, and we also have shell.exe. There we are. So what we need to do now is essentially identify the actual key that we want to use. As I said, in this case, I'll be using the key 33. So what I'll do here is, let me just head over to the keys. Let me see if I can find them here. There we are. So if we take a look at the key 33, we should be able to learn more about it. And of course, I've explained it here. So that is 33. There we are. So that essentially targets the FOD helper.exe. So again, performing or bypassing UAC is fairly simple. All you need to do is, let me open up a command shell. There we are. And then I'll execute HackerSploit. There we are. So what I can do now is execute HackerSploit64.exe and then specify the key or the technique that I want to use, which is 33, and then specify the path to the executable that I would like to execute with elevated privileges, and consequently bypass UAC, the UAC prompt. So this is under users and IE user, and the name is shell.exe. So what will happen now, once I hit enter, I should receive a Meterpreter session in my second window here that will be elevated. So I'll hit enter. As you can see, it sends the stage and we get a Meterpreter session. So let's take a look at the permissions here. So if I say, get user ID, you can see I'm still as IE user, which again, you might be a little bit confused by. But again, if we take a look at the privs, you can now see I have all the privileges you typically associate with the administrative account, right? So again, just to verify that this is the case, I'll also do it here. So get user ID, and we can then say get privs. So this is the unprivileged session, and this is the privileged session here. So, if I was to open up a shell, and if I say, who am I? You can see I'm still IE user. So what I can do, because I have administrative privileges, I can locate the LSAS process, for example, and migrate into it. So I can say migrate 6 to 8, hit enter. And we'll give this a couple of seconds. There we are. So if I now say get user ID, NT authority system, and we've successfully elevated our privileges by bypassing UAC with UACMe. And of course, I can open up a shell session and verify that that is the case. So, I can now perform tasks like hash dump, and there we are. I've been able to dump the hashes, so on and so forth. So that is how to bypass UAC with UACMe. As I said, it's fairly simple once you've identified the technique that works. And whenever you're testing these keys or techniques, I recommend setting up a sandbox environment or a sandbox system that is essentially the same as the target system, so that you can test and see what works. And in this case, you can see how simple that was. And of course, the actual compilation is equally simple. So this was a technique that I wanted to highlight because not a lot of penetration testers actually utilize or take advantage of UAC in terms of privilege escalation. And the reason for that is because there's multiple techniques that you can use. However, UACMe essentially simplifies all of that and actually provides you with 60 techniques. Most of them have been fixed, but as I said, there are still a few others that you can utilize to bypass UAC. And of course, if you're targeting a system that's running an old version of Windows, maybe Windows 7, Windows 8, 8.1, then most of these techniques still work. All right, so that is going to conclude the practical demonstration side of this presentation. All right, so that concludes this presentation. Thank you very, very much for having me. I really appreciate it. And of course, I had to work within the time constraints of the presentation. So again, if you would like to learn more about this, do check out the actual UACMe GitHub repository. If you'd like to learn more about penetration testing, red teaming, privilege escalation, malware analysis, you can check out my YouTube channel, which is youtube.com/HackerSploit. And once again, thank you for having me here, and hopefully I'll see you again next year.